To find the Maclaurin series of a cosine, we would apply the definition where we need successive derivatives of the cosine. So f of x would be f of 0 divided by 0 factorial times x to the power 0 plus the first derivative at 0 divided by 1 factorial times x to the power 1, etc. So we need to take successive derivatives of f of x, or derivatives of cosine. So let's start by finding f of 0. So f of 0 is simply cosine 0, which is 1. Now the first derivative of x, or the first derivative of cosine 2pi(x) will be sine or minus sine 2pi(x) multiplied by the derivative of the argument, so that's multiplied by 2pi. So that's our first derivative, and if you were to substitute x equals 0, we have f dash of 0 is minus 2pi times sine 0, which happens to be 0. Now, if we differentiate again to find the second derivative, the derivative of a sine is cosine. And again, we multiply by the argument, so it's minus 2pi now squared cosine 2pi(x). And again, if you find the derivative at x equals 0, that's minus 2pi squared times cosine of 0, which is 1. And if we do that a third time, so if you differentiate the cosine, you now get negative sign, so the negative with the negative becomes positive, and we have 2pi again, so it's cubed, sine 2pi(x). And again, if we were to substitute x equals 0, sine 0 is 0, so that simply gives us 0. And the fourth derivative, so the derivative of a sine will be cosine, and now we have 2pi to the power 4. And at x equals 0, again, cosine 0 is 1, so we have simply f4 of 0 is 2pi to the power 4. So you notice how the sign changes between negative and positive. So if we're to write the Maclaurin series, it looks something like a 1 over 1 factorial times 1 plus 0. So this 0 is there, plus negative 2pi squared over 2 factorial times x squared plus 0. So again, this 0 is this 0, plus 2pi to the power 4 over 4 factorial times x to the power 4, again plus 0, etc. So we can rewrite that as a summation from n equals 0 to infinity. Now, if you look carefully, what we have is denominators which are even and powers which are even. And we can write even numbers as 2n. So we multiply that by x to the power 2n, and we make sure that the alternating signs of negative, then positive, then negative are encoded using a negative 1 to the power n. So negative 1 to the power 1 would be negative 1. Negative 1 to the power 2 would be positive. So for our first term here, with x to the power 2 and 2 to the power, or 2 factorial in the denominator, n would be equal to 1, and minus 1 to the power 1 would be negative 1, so the minus sign. And for the next term, where n equals 2, we would have a positive sign. So even though we could probably simplify this further, I'm happy to leave this as our final answer for the Maclaurin series for cosine 2 pi x.